Apart from differentiation of elementary function, the list of formulas that you have to remember, you also have to remember some rules of differentiation. So let's start with the first rule of differentiation. It says that whenever you are differentiating a constant with respect to some variable, it will always come out to be 0. The idea is very clear. If the function is constant, so it's not going to change, that's why its rate of change would be 0. For example, if we have to find differentiation of, let's say, 5 with respect to x, it must be 0. Same goes with any other number, or let's say some other constant. So if I differentiate, let's say, pi with respect to x, it will also come out to be 0 because it is constant. Now let's discuss second rule of differentiation, that is constant multiple rule, that says if you are differentiating a function fx with a constant multiple, that means c into fx. If you are differentiating c into fx, then it can be written as c times differentiation of fx, or the rate will increase by c times. So in a way, if a constant appears as a multiple, you can take it outside d by dx and differentiate the rest of the function. For example, if you are differentiating three into sine x, then you can write it as 3 into differentiation of sine x, and so the result will become 3 into differentiation of sine x, which is to become 3 into, you can see here, differentiation of sine x is cos x. Yeah. So it will become 3 into cos x. Once you are done with the differentiation, you can drop the operator sign d by dx. So the answer is 3 cos x. Differentiation of 3 sin x is 3 cos x. Another example would be, suppose you are differentiating pi into ln x. So you know the differentiation of ln x, but pi is a constant. So you can take pi outside and then write d by dx of ln x. You know the differentiation of ln x? See from here, differentiation of ln x is 1 by x. So you can write it here, pi into 1 by x. Our answer will become pi by x. So every time there is a constant, multiply with some function. During differentiation, you can take the constant outside. Here 3 was constant and was taken outside of d by dx. Here pi was constant and taken outside of the d by dx. Let us discuss third rule of differentiation, which is called sum rule, which says if you are differentiating a function which appears as sum of two functions, fx and gx, then differentiation will be equal to sum of the differentiation of individual functions. That is differentiation of fx plus differentiation of gx. For example, if we have a function y is equal to, let's say, x plus sine x, then you can see y is a function of x and appears as sum of two functions, x plus sine x. So this is our fx here, and this is our gx. And suppose we are trying to find dy by dx, and we can write it as dy by dx of sin x, which appears as fx plus gx. Then, according to this rule, we can split it and differentiate x first, then differentiate sin x. Now you can apply elementary formula for the differentiation of x and elementary formula for differentiation of sin x. This is x to the power 1 here. So you can apply this rule, the first rule here, that differentiation of dy dx of x to the power n is nx to the power n minus 1. So we'll have here 1, then x to the power 1 minus 1, because n is 1 here. So n x to the power n minus 1 plus differentiation of sin x. You can apply this elementary formula, that differentiation of sin x will be cos x. So you can write it here, that dy dx of sin x will be cos of x. Now you see, this is x to the power 0, which will be 1, then plus cos x. This will be the final answer. The differentiation of x will give you 1 and differentiation of sin x will give you cos x. Let's take another example. Suppose we have y equal to x plus 1 by x. Then if you have to find dy by dx, then it is simply d by dx of x plus d by dx of 1 by x, because differentiation of y here, dy by dx, is d by dx of x plus 1 by x, and it converts into this applying sum rule, that differentiation of y will be differentiation of x here plus differentiation of 1 by x, which is here. So you can proceed further now. This one is x to the power 1 here, and this one you can write it as x to the power of minus 1. You see, we can do that. We can write it as x to the power minus 1. This will be nx to the power n minus 1. So 1x to the power 1 minus 1 plus differentiation of x to the power minus 1 will be minus 1 x to the power of minus 1 minus 1. So after applying this formula here, we can get it as x to the power 0, and this will become, there will be a minus sign here because of this. So we'll have minus x to the power of minus 2. So if we further write it in a concise way, x to the power 0 is 1, and minus x to the power minus 2 can be written as 1 by x square. So the differentiation of x plus 1 by x would be 1 minus 1 by x square. We have used sum rule here. This rule is also valid if there is a minus sign in between. If there is a minus sign here, then there will be a minus sign here. So this notation is called dual sign notation. That means if here there is a plus sign, then on the right hand side this will be plus sign. If there is a minus sign on the left hand side, there will be minus sign on the right hand side. For example, if we have to differentiate d by dx of, let's say, x square minus x, then we can apply some rule here and use the lower minus sign here. So differentiation of x square minus sin x would be differentiation of x square minus differentiation of y square minus differentiation of x. Now this is n here is 2. We can write it as 2x to the power 2 minus 1, which is 1. Here you can write it is x to the power 1. So 1 x to the power 1 minus 0. Applying the first formula here, then you will have 2x minus x to the power 0 is 1. So the answer for this will become 2x minus 1. Applying this formula and sum rule. Using a minus sign over here, important point to note is there is a minus sign over here, then there is a minus sign over here. Now let us discuss fourth rule of differentiation, which is called product rule. It says if you are differentiating a function which appears as product of two functions fx and gx, so fx into gx, then the differentiation is equal to fx into differentiation of gx plus gx into differentiation of fx. So here this is the first function. If I say this is the second function, then you can remember the product rule as first function you take it as it is and differentiate the second function. So fx into differentiation of gx plus second function into differentiation of first function. You can remember the result like this. Here the order is not important, whether you differentiate fx first or gx first. For example, suppose we have to differentiate a function which is x sine x. Then we can write it as, after identifying this is our first function, this is our second function. So you can say it is equal to x into differentiation of sine x using this rule plus sine x into differentiation of x. The result follows x into differentiation of sine x. Differentiation of sine x is cos x plus sine x into differentiation of x. Differentiation of x is x to the power 1. You know the differentiation of x to the power 1 will be 1 into x to the power 0, which is 1. So final answer would be x cos x plus sine x. Let's take another example. Suppose you have to differentiate a function which appears as x ln x. Then it would be x into differentiation of ln x plus ln x into differentiation of x using product rule. Then you can apply differentiation of elementary function here. Now you can see d by dx of ln x. D by dx of ln x is here. You can apply this formula here. So it will become x into differentiation of ln x, which is 1 by x plus ln x into differentiation of x, which we know is 1. So the answer would become x will cancel out and you will have 1 plus ln x. The next rule of differentiation is known as quotient rule. It says if a function appears as fx by gx, division of two functions, then the differentiation of the entire function would be the denominator into differentiation of numerator minus numerator into differentiation of denominator divided by denominator square. It appears quite big, but if you remember the order, it's quite easy. So what you have to remember is there's a minus sign here. So the order is important, whether to differentiate numerator first or denominator first. So here you can see, first of all, you have to differentiate the numerator, then denominator. For example, suppose we are differentiating a function given by x by sin x. following this quotient rule, we can apply here. You take the denominator up. You take the denominator up, then it will be sin x multiplied by the differentiation of numerator. Differentiation of numerator is d by dx of x minus x into differentiation of denominator, and the last step is you have to divide the entire term by denominator's square. So it will become sin x and then there is a square over here. Now you can use elementary formula to proceed. We have sin x into d by dx of x would be sin x into 1 because differentiation of x is 1. Then x into differentiation of sin x. You can use this formula, differentiation of sin x is cos x. So here it will become x into cos x divided by sin square x. So you can write the result here. It would be sin x into 1 minus x into differentiation of sin x is cos x, then divided by sin square x. It is same as sin x to the power of 2.